pots and pans. So, now one other thing to note. How many carbon atoms do I have on the reactant side here? How many?
One.
And how many do I have on the product side? How many oxygen atoms do I have over here?
2.
And on the product side?
2.
This reaction is said to be balanced because I have the same number of each element on both sides. Some books, and I don't think your book uses this terminology, but most books refer to this as the law of conservation of mass. Okay? Who in here is a deity? Anybody here a deity? Everybody know what a deity is? What's a deity, Shoes?
It's like a godly.
A god. Anybody here a god? We probably don't even have any saints in here, do we? Anybody here a saint? Nobody's been elevated to sainthood yet? So you're definitely not a god if you're not at least a saint, right? So we're all down here somewhere. So because you're not a god, you cannot produce or destroy matter. Fair enough? All the matter in the universe is the matter in the universe. It's all there. You cannot make new matter. Because of that, the amount of matter that is on the reactant side has to be equal to the amount of matter that's on the product side. So if I have one carbon on the reactants, I have to have one carbon on the products. If I have one oxygen, I have to, or if I have two oxygens, I have to have two oxygens. Okay? Has to be. Bless you, in order for this reaction to be written correctly, that's what has to occur. Okay? And we're going to talk about, this is called balancing an equation. How do you do that? How do you make it, if it's written like this and it doesn't balance, how do you fix it is the question. Okay? How do we balance an equation? I'm going to do one by example. Okay? I'm going to make a new slide. Here's how I do it. I make a chart. And I put my initials up here. You must use my initials, not anybody else's initials. Why my initials? Why do you use my initials here? Reactants and products. This is the Rodney Powell chart. No, reactants and products. You'll remember it now, though. And then I'm going to make a list of all my reactants, all the elements that occur as reactants and products. In this one, I have aluminum, and I have sulfur over here. Do I have any other elements over here? No, right? All I have is aluminum and sulfur. Then I'm going to fill out this chart. How many aluminum atoms do I have on my reactant side?
1.
And how many aluminum atoms do I have on my product side?
2.
How many sulfur atoms do I have on the reactant side?
3.
Reactant side?
1.
1. And on the product side?
3.
Now, if this reaction was balanced, if it was written correctly, I'd have the same numbers in the reactants column as I do in the products column. These should be equal, but they're not, are they? Uh-oh, we got a problem. Here's how we fix it. There's only one way to fix it, and that's to use what we call coefficients. I'm going to put a 2 here. And when I put that 2, it means that I have 2 aluminums here. And I'm going to put a 3 here. It means I have 3 aluminums there. Now, is this column equal to this column?
Yes.
It is now balanced. Now, note, you can only put coefficients. You cannot change the formula. I was not allowed to change that 2 to a 1 and the 3 to a 1 so it would work, because that is the wrong formula for aluminum sulfide. Okay? You cannot change formulas. You can't put numbers in the middle of a formula. The only thing you can do to balance it is to put coefficients in front of the formulas. Okay? Shall we practice some more balancing? Well, this one, the next couple slides are just for you to practice how many atoms are on each side, okay, before you go to balance. So, let's look. How many phosphorus atoms do I have right here?
4.
And how many do I have over here?
4.
Phosphorus. How many phosphorus atoms on this side right here?
4.
There are 4, right? The coefficient in front multiplies everything, okay? Now, how many bromine atoms do I have right here?
12.
12.
I have 12, right? 6 times 2 means I have 12 bromine atoms. Do I have 12 on the product side as well?
Yes.
Yes, I do, because 4 times 3 means I have, dang, gummit, means I have 12 here as well. Okay? Now what about for B? How many aluminum atoms?
2.
I have 2 here, and how many do I have on this side? 2. Does it matter that over here it's a coefficient and here it's a subscript? No, doesn't matter. All we're doing is counting how many we have, okay? For iron, how many do I have here? And how many do I have here?
2.
Oxygen I have
3.
3, and over here I have 3. Anybody want to name this compound right here? Anybody want to name this one?
Iron, Roman numeral 3, oxide.
Iron 3 oxide. All right, what about this one?
Oxide.
Didn't y'all take a quiz for chapter 4?
Aluminum oxide.
Who said it? What did you say, Maggie?
Aluminum oxide.
So it's just aluminum oxide, isn't it? You don't need a Roman numeral, do you? Because aluminum's 3 plus. No Roman numeral, it's not a transition element. Okay, good. All right. Want y'all work on this problem for a minute. Here's a good question for you. I'll do it for you on the board. We'll do it together. If somebody can name this first. Well, what are our steps? What's oxygen always? What's charge on oxygen?
2.
2 minus times 4. So that's 8 negative charges. Divide that by what? 3. 2.6. 2.7. This is a mineral. This is called magnetite. I think that's what it is. It's not 2 or 3. It's in between.
So they don't all have, just because it's iron doesn't mean it has to have a Roman.
This one's very odd. Some of these atoms are 2 and some are 3. Yeah.
Most of them do have the Roman numeral if they're iron.
It would, yeah, our naming system doesn't account for this kind of weirdness like this. Yeah. This is very unusual. You
Won't
won't
be on the test, right?
be on the test. I just thought I'd see who could think through it a little bit. All right. But that critter is one of our reactants, right?
Yes.
And what's its state?
Solid.
So it's a solid. So I'm going to put an S. And what does it react with?
H2.
Hydrogen, and we said it's diatomic. Oh, I should be able to write it 2, huh? So I'm going to put a 2, and it's a gas. And I put the arrow. What are my products? Iron, and it is solid. And what else?
H2O.
H2O. And I said it's going to be a liquid. Now we have to balance it, don't we? What's my list? Iron, oxygen, and hydrogen. How many irons do I have on the reactant side? 3. And on the product side, just 1, so why don't we fix it? Let's put a 3 right here. And that makes that work, right? All right, what about oxygen? How many on the reactant side?
4.
And on the product side,
1.
just 1. So I have 4 and 1, so to fix it,
4.
put a 4. And that gives me 4. Hydrogen on the reactant side,
2.
2. And on the product side,
8.
I have 8, right? 4 times 2 is 8. So how do I fix that?
You put 4 on the.
I'm going to put a 4 right here. And that means that this is now 8.
So when you put the 4 in front of the hydrogen 2, it automatically makes the oxygen a 4?
No. Oh, when I put it here?
Yeah, when you put it in front of.
Yeah. It's in front of this whole formula, right? So that's like saying that that's a good question, Maggie. That's like saying I have
So you have 4 H.
I have 4 H2Os.
Okay.
There's 1 oxygen in every one of them, and there's 2 hydrogens in every one of them.
So there's 4 oxygen.
So there's 4 oxygens and 8 hydrogens here. Yep.
So it won't matter what order you do the oxygen and the hydrogen when you're balancing.
No,
It's still come out the same.
it should, if you do it correctly. And it also doesn't matter which order you write these in over here. I could have put water plus iron. It doesn't matter, okay? Everybody okay? Everybody understand that? Okay. Students in the other class go, well, let us practice one more like that.
Yeah, that's a good idea.
Don't want to practice one more like that?
She's done it all.